In last class about 15th group elements in p block elements, last concept is oxides of phosphorus explained: trioxide, tetroxide, and pentoxide. Among these two explained. One is trioxide and one is pentoxide. And two structures given. Based on two structures, maybe they'll ask in objective number of sigma bonds, number of lone pairs, and how many pi bonds are there. Linkage, phosphorus, oxygen, and phosphorus linkage. Okay. Anyhow, so today we'll discuss about in p block elements another part, that is another important group, that is 16th or 6th A group elements are oxygen family and chalcogens. Anyone just take 15th group elements. In 16th also, here chalcogens new word is introduced. In 15th group elements are called generally nicogens, suffocating, creating gases they are. But here these 16th or oxygen family, these group elements are collectively called chalcogens. Why these are called chalcogens means gens is the generation, formation, producers. Chalco means here ore farming elements. That's why these are called generally chalcogens. Means these 16th group elements combines with some other important any metals or the non-metals. It creates some important ores or the minerals. In metallurgy, that is isolation and principles and processes of isolation of elements given clearly about ore, mineral, gangue or the matrix, flex, slag. Similarly, here ore forming elements means chalcogens. They are by using 16th or 60th group elements. Here oxygen, sulphur, or selenium, tellurium, and polonium are collectively called 16th group or 6th A group. 6th A group elements. These are also called chalcogens. Chalcogens these are. So are the sulfur, oxygen, sulfur, selenium, tellurium, and polonium are collectively called. So why these are collectively called chalcogens means these sulfur and oxygen form some important ores or the minerals. So here main important thing is about occurrence of these 16th group elements. Generally here about oxygen, your oxygen nearly your 46.6% by mass exist in earth crust. It is. So in earth crust, under the name of their oxides exist your 46.6%, just like zinc oxide or magnesium oxide. Some oxides are available in earth crust. Your percentage is oxide 46.6%. Nearly the 20.964% by volume available in dry air. So are the dry air contain nearly along with some other important gases. Main abundant gas is this oxygen. So for all living system and non-living system, this oxygen required. Yeah, to survive the lives continuously for a long time, we want this pure and dry oxygen. So in atmospheric air, this pure and dry oxygen percentage by its volume 20.96 percentage. And some organic and inorganic compounds containing oxygen under the name of their alcohols or carboxylic acid or aldehydes and ketones, like different organic compounds containing this oxygen. In second year, in 12th standard, we have an important unit, organic chemistry, organic compounds containing oxygen. Organic compounds containing oxygen means here OH group alcohols are there. Phenols are there, like PHO. Ethers, R bond OR, ethers. Alcohol phenol ethers, like carboxylic acids, aldehydes, and are the ketones. Organic compounds containing oxygen, like this is already completed in organic part under the name of alcohols, phenols, and ethers. Now, next coming unit, that is in 12th standard, that is second PUC, big chapter, that is carboxylic acids, aldehydes, ketones, or ketones, aldehydes, ketones, and carboxylic acid unit. Then next one is about sulfur. So generally, your sulfur percentage is very less. In earth crust, nearly 0.03 to 0.1 percentage. 0.03 to 0.1 percentage is present in earth crust. Earth crust under the name of sulfides, as sulfides as well as sulfates. So the sulfur exists as sulfides as well as sulfates. Here some important sulfides are metallic sulfides are ZnS, zinc blend it is. Now here the PbS, lead sulfide, galena this is. Here mercuric sulfide, here Ag2S, like your CuFeCFeS2, copper pyrites, iron pyrite FeS2 is there. We know the mixture of Cu2S and FeS2 or FeS, combination in metallurgy given this is sulfide ores. Like these are some important sulfides of are the metals, some important metals, zinc, lead, mercury, silver, copper, and iron, like these. Now some important sulfates are there, very important sulfates. Yeah, important sulfates are here, main three important sulfates are there here. It is reacted with the barium, that is called a barite. That barite formula is BaSO4. Then here Epsom salt, like Epsom salt, this is one is gypsum salt. So the Epsom and gypsum salts are very important. Which of the following is a barite or gypsum or Epsom salt? Here this is Epsom salt is MgSO4 7H2O, this is heptahydrated magnesium sulfate. Gypsum salt is the CaSO4 and 2H2O. This is bihydrated copper calcium sulfate. So these are the three important sulfates of metals like barium, magnesium, and calcium. Maybe in examination, maybe they will ask in examination, which of the following metal is present in a barite? Options they'll create barium or magnesium, calcium or zinc, like they'll create in a objective examination about these ores. So the Epsom salt contains mainly the metal is magnesium or calcium or barium like. Or which of the following is an example of Epsom or the gypsum salt? These are the some important occurrence, some important ores or some important materials as sulfides and sulfates of this sulfur. Remaining elements of this 16th group elements like selenium and tellurium as exist as a metallic selenides and tellurides exist as. But here the polonium is a radioactive element. A radioactive element. This radioactive element easily disintegrate and it converted into other important forms. It is a short-lived lived element that half-life period in physics already explained, and in chemistry also explained to you about half-life period based on a rate constant, rate of the reaction. T of half-life period is 13.8 days. Very short lived half-life period element. This is polonium. So these are the some important points about 16th group elements: oxygen, sulfur, selenium, tellurium, and polonium. Okay. Next one is the next important point about 16th group elements is general electronic configuration. Next one is about general electronic configuration of our 16th group elements. Now its general electronic configuration is rare gas, NS2 and NP4 is the general electronic configuration. In its outermost orbit, S subshell contain 2 electrons and P subshell contain 4 electrons according to Hund's rule. Here each orbital is filled with one electron, remaining electrons are paired up. These two are paired that is completely filled. These two are half filled, not half filled, that is partially or singly occupied, that is single electrons are there. These two pairs are there and 2 are the unpaired electrons, unpaired present. So based on this, generally ready to form 2 covalent bonds, the 16th group elements. Here element is first element, name of the element. Here symbol and atomic number and its electronic configuration. So here very important, based on this only, here I'll get some important anomalous properties of oxygen, like first one is oxygen, symbol is O, atomic number is 8. Its electronic configuration 1s2, 2s2, 2p4. Here d orbital, d subshell is not present. Just take in now 15th group elements, nitrogen, absence of a d orbital in its outermost orbit. Nitrogen do not show any peculiar, means do not show any some important properties, or it exhibit different properties, anomalous properties, just like nitrogen. Oxygen also show some anomalous properties. Now in its outermost orbit, in second main energy level, Here 2 electrons and here 4 electrons are there. Here 1, 2, 3, 4. There is no electrons. To excite these 2p electrons and also 2s electrons, there is no d orbital, that is unavailability. Unavailability of d orbitals or the d subshell. It shows some peculiar properties. So maximum, it forms maximum covalency, do not excite either s and 3p orbitals only involved in oxygen. That's why maximum covalency for oxygen is 4. Because these 4 only participated. That's why for oxygen, maximum covalency based on this, that is 4. Do not exceeds more than 4 because absence of d orbitals. To show 4, 5 or the 6 like maximum covalency, availability of d orbital required. Absence of d orbital, do not exhibit. That's why it shows some peculiar anomalous properties. Very, very important. Electronic configuration based almost all some important points based on this simple electronic configuration and that point. Now here the sulfur, next one is sulfur. Symbol is S, add 8 will get 16. Electronic configuration is 1s2, 2s2, 2p6, your 3s2, 3p4, 16. 3d orbitals are there, availability is there. So due to the availability of these, for sulfur onwards, maximum covalency is 6, not more than 6, because in its outermost orbit how many electrons are there? Maximum 6. They are excite maybe from 3p to 3d, 3s to 3d orbitals. Now here after sulfur, selenium. Here selenium Se, to this 16 add 18 will get 34 atomic number. Now just like this sulfur here, take neon electronic configuration, that is 10, just like here it is argon 18, 3d 10, that is 28, like 4s2 30 and 4p4 34 balanced. And here 4d orbitals are available. Then next important thing is tellurium. Your tellurium Te, add 18 here will get 52. Your electronic configuration argon krypton 36. Your 4d10, 5s2 and 5p4. Similarly, here polonium. Polonium, that is PO, add 32, atomic number is 84. This is xenon, your 4f14, your 5d10, 6s2 and 6p4 is the electronic configuration of polonium. This is a very, very important table, just observe it. In this table, main important thing is oxygen electronic configuration is main important. This is oxygen. So in oxygen, in its outermost orbit, d orbitals are absence of d orbital, do not excite. That's why its maximum covalency is 4. But based on their electronic configuration, whenever atomic number increases, your d orbitals are available. They are excite from lower energy level to the higher energy level, and it shows maximum covalency is 6. Okay. Now, based on this, based on electronic configuration, we can easy to explain some important properties, just like here after electronic configuration, atomic or the ionic radii, easy to explain. based on their atomic or ionic radii, easy to explain ionization energy, electron affinity, electronegativities, density, melting and boiling points. Some important physical properties easy to explain about these 16th group elements. So once we can observe this electronic configuration, here 2s to 2p4, 3s to 3p4, 4s to 4p4, 5s to 5p4, 6s to 6p4. Top to bottom energy levels, what happens? Increasing. That's why size automatically increases. That's why here once we can observe in this ns2 and np4 here, n start with 2, 3, 4, 5, 6. This is. On its outermost orbit, 2 and 4 are there. ns2, np4, that is 2s2 to p4. So based on this electronic configuration, some important properties about these 16th group elements are, first one is atomic size. Atomic or ionic size. Already in 15th group elements and in first PUC periodic table and chemical bonding about radii, types of radii explained. Just overall idea about this atomic or ionic size. So once we can observe here this electronic configuration as n value increases. N value means number of energy levels, orbits. Here n indicates your energy level, main energy level, or shell it is. As n value increases, your atomic or ionic size. What happens? Ionic size increases. But experimentally, once we can observe, top to bottom atomic size increase, but here polonium is a radioactive element. Due to its radioactive nature, after 13.8 days, what happens? It disintegrates, decomposes, size somewhat decreases. That's why while explaining some important properties, generally won't consider this polonium radioactive element. Better you remember, note down on important point in this 16th group elements while explaining some important relations or the points. Yeah, the polonium properties are somewhat negligible because radioactive some different properties are there. Size decrease. That's why we can say easily your oxygen size is less than sulfur, than selenium, than tellurium. This is important. As the size increases, ionization energy IE or IP, ionization potential, is directly or inversely proportional. Ionization energy increase when size decreases. That's why this is inversely proportional to its size. So the ionization energy is more for oxygen than compared to sulfur, than compared to selenium, than compared to the tellurium. This is. Whereas in case of electron affinity, very, very important. In first PUC, periodic table, in periodic table explain, in the periodic table in each and every one group, that is P block elements, every second element in that group has highest electron affinity element. Among all known elements, highest electron affinity element is Cl, chlorine. Electron negativity element is fluorine, F. That's why here electron affinity is more for sulfur than compared to the oxygen. So we can say as like your oxygen is less than sulfur because your oxygen electron negativity is more, but affinity is less because oxygen, sulfur, selenium and tellurium, top to bottom size increase, electron affinity means To this neutral isolated gaseous atom, one electron is added, easy to accept, and more amount of energy is released. But in case of oxygen, due to its small size, when our electron is added to this, inter-electronic repulsions takes place, electron affinity decrease. That's why sulfur has highest electron affinity than compared to the oxygen. Then here fourth one is electronegativity. As usual here, oxygen is more than compared to sulfur than selenium, than tellurium and polonium. These are the some important points about 16th group elements. Okay. Generally, here next one is generally density. We know density of this 16th group elements. Density D is equals to mass by volume. So as top to bottom, your atomic number increases, atomic size increases, proportionately to mass also increases. That's why the density order is oxygen is less than, sulfur is less than, selenium is less than tellurium. Density order this is. The next one is your sixth one is melting point, and here boiling point. Generally, melting and boiling points are generally here sulfur is more means compared to the oxygen, sulfur is more melting are the boiling points. So are the melting and boiling points while comparing these two generally here melting and boiling points are of these 16th group elements are generally there are difference large difference in melting and boiling points. So are the melting point of oxygen and the boiling point of oxygen, melting point of sulfur and the boiling point of sulfur. There is a large difference in their melting and boiling points of each and every one element. So are the large difference in their melting and boiling point is due to atomicity, is due to atomicity of 16th group elements. Now here generally oxygen is a diatomic gas. Diatomic gas it is exists as a O2 at room temperature. But here the sulfur exists as a polyatomic. So due to the polyatomic nature means sulfur exists as S4, S6, S8 in atomic states. So due to the your atomicity, it is a diatomic, it is a polyatomic atomicity. So are the due to its atomic nature, diatomic and polyatomic, their melting and boiling points also varied. Here generally sulfur is a polyatomic, having generally melting and boiling points are more than compared to the sulfur. Then again slightly your atomic number increase, atomic mass increase, melting and boiling points also increases. But polonium generally we can't because it is a radioactive element, it is integrated. So once we can observe all these properties like atomic size, ionization energy, ionization potential, electronegativity, electron affinity, melting and boiling points, and density are these elements, not compounds, like one table created in our textbook. Better you read from textbook the table, very very important. Increasing and decreasing order of their melting and boiling points, densities, and all these general properties. Clear about 16th group elements introduction? Then Next one is anomalous properties of oxygen. Why are the oxygen exhibit anomalous properties? Already in 15th group elements explained about anomalous properties of nitrogen, just like nitrogen. In oxygen also, in 16th group elements also, oxygen exhibits some peculiar anomalous properties. Reason is the same, just like 15th group elements. In 15th group elements explained to you, that is nitrogen shows some anomalous properties compared with the same family members, other elements, due to its small size, high electronegativity, and or high electron means high electron negativity and high ionization energy, absence of d orbitals. Nitrogen exhibits some anomalous properties. Similarly, in 16th group elements also, oxygen shows, here the oxygen shows some anomalous properties. Anomalous properties due to its first one is small size. Second one is high electron negativity or ionization energy, and third one is unavailability of d orbitals in its valency shell. Due to these three important points, your oxygen shows some anomalous properties, peculiar properties. So many are there examples, so many are there. Their boiling and melting points and their oxides. One simple example is for this to show the anomalous properties. Your H2O is a liquid at a room temperature, liquids, whereas H2S is a gas at a room temperature. At a room temperature. This is the main important property. Here oxygen shows anomalous. In both the cases, here hydrogen and hydrogen both are the same, but it is a liquid, it is a gas. Reason is, in H2O molecule there exists a, due to the presence of intermolecular hydrogen bond HB. Reason for that, presence of intermolecular hydrogen bond at room temperature, it exists as a liquid, whereas it is gas. That is due to the presence of van der Waals forces, weak van der Waals forces. Due to this reason, it is a gas, it is a liquid at room temperature. Like a variety examples are there to show the peculiarity, anomalous properties of oxygen with other same family members. Okay. So based on this, generally here physical state, in this physical state of this 16th group elements, your oxygen and oxygen is a gas at a room temperature. Here the sulphur, selenium, tellurium and polonium are solids at a room temperature. Then here oxygen and sulphur are purely non-metals. Here selenium and tellurium are the metalloids, and polonium is a metallic radioactive element. Metallic radioactive element it is. Already given, its half-life period is 13.8 days. Very short-lived element it is. Okay, so these are the some important points about anomalous properties of oxygen. Then chemical properties, very important, that is variable oxidation states exhibited by these 16th group elements. Discuss about variable oxidation states. There are variable oxidation states of 16th group elements. In this 16th group, element A is equals to oxygen, sulphur, selenium, tellurium, and polonium. These elements are collectively called 16th group elements. First about oxygen. So the oxygen are common oxidation or not only oxygen for these 16th group elements, common oxidation state is -2 generally this is. And common for all elements. And oxygen and some other elements shows variable oxidation states. For oxygen and different compounds exhibit different oxidation states. Depending upon their combining capacity and type of elements combined with oxygen, it shows variable oxidation states. Generally here -2 oxidation state in general oxides. In general oxides means like H2O water, general oxide. Calcium oxide is a general oxide. Magnesium oxide is a general oxide. Al2O3 is a general oxide. Like in all the cases, oxygen exhibit -2 oxidation state. It also exhibit -1 oxidation state. That is in peroxides. In peroxides means here hydrogen peroxide, H2O2 this is. In like potassium peroxide, like here sodium peroxide, like it exhibit NaO2 or Na2O this is. Sorry. Here sodium is here +1 oxidation state. Compulsory it is -1 oxidation state exhibited. That's why here NaO like peroxides. Or lithium monoxide, here Li2O is a lithium monoxide because here Li +1 and O -2 by crisscross method. Like peroxide, like Na +1 and O -1 by this method, like NaO like this. Peroxide means compulsory oxygen and oxygen linkage required. That's why NaO2 like this. And here NaO2 means like this here O, Na2O2 like this. Like oxygen and oxygen linkage and Na +1, here Na +1 that is. So in peroxides, it exhibit -1 and in superoxides -of. In superoxides, it exhibit -of like here K2O like this. Here it is KO2 this is because here K +1 O- of 2 are there, into 2 get cancelled. Your K plus 1 and your the O minus half into 2 are there, 2 like this, get cancelled. So are they in superoxides, it exhibit oxidation state is minus half, like we can take O minus 1, it is a superoxide. It is a superoxide, like O2 minus 2 is a peroxide, it is. Superoxide and peroxides. In chemical bonding, in molecular orbital theory, we know about bond order in superoxides and bond order in peroxides. And it also exhibit +2 oxidation state and +1 oxidation state also. Like in OF2, oxygen difluoride OF2. Oxygen is least electronegative than compared to fluorine. Fluorine is -1 into 2, -2. Oxygen is compulsory +2, this is. That's why, yeah, +2 oxidation state in oxygen difluoride. +1 also, that is in OF, oxo monofluoride, like OF. So here -1 and +1 oxidation states. That's why for oxygen it shows -2, -1, -half, +2 and +1. These are the variable oxidation states exhibited by oxygen depending upon the type of element combined with oxygen. So while calculating while calculating oxidation state of some other elements, oxygen identify is it a general oxide or peroxide or superoxide or oxo acids of fluorine, like oxygen combines with the fluorine, it gives corresponding compounds. Then after oxygen, after all these oxidation states, sulfur onwards, for sulphur, selenium, tellurium and polonium, its oxidation state generally shows +4 and +6 oxidation state also. For oxygen here, -2, -half, -1, -half, +2 and +1. Whereas in case of these remaining elements, like for sulfur, selenium, tellurium and polonium, shows here -2 common, that is common oxidation state for this group, and here +2, +4 and +6 also exhibit. So are the sulfur to polonium, sulfur, selenium, tellurium and polonium, your formation of our to exhibit +6 oxidation state decreases. Why? Your +6 oxidation state decreases top to bottom, like leave it this oxygen atom. Sulfur to polonium, your oxidation state of these elements +6 decreases. +4 oxidation state increases. Why? +4 oxidation state increases in this case. Means sulfur shows here the +4 and +6. Here +4 and +6. Here +4 and here +4 only. Maximum do not. Why here the formation of +6 decrease and +4 increase means stability of formation of +4 increase means that is due to inert pair effect. So the inert pair effect are clearly explained in 15th group elements. Ns electrons do not involve. Reluctance of Ns electrons in a chemical bonding or while forming any one compound, Ns electrons of valency, electrons of any atom of element do not involve. Particularly any atom of an element means based on this group, particular group. Top to bottom, inert pair effect increase, Ns electrons do not involve. So here we know 16th group elements. General electronic configuration, that is NS2, NP4. This is whenever top to bottom size increases due to the pore shielding effect, due to the pore shielding or screening effect, your inner pair effect increases. These NS electrons, nuclear force of attraction directly influences on valence electrons, NS electrons. These NS electrons do not involve in a chemical bonding. These 4 electrons only involve. That's why its maximum oxidation state is for polonium +4 only. But sulfur shows +4, +6 and +2, -2 also exhibit. This is the complete explanation about variable oxidation states of 16th group elements and some important physical properties. Tomorrow I'll explain about reactivity towards hydrogen, oxygen and halogens of 16th group elements. Compared to the 15th group elements, 16th group elements somewhat small topic. Then compared to the 16, 17, again somewhat small topic. Number of compounds and chemical properties are less. Then again 18th group again somewhat less. That's why better you concentrate, better you read thoroughly first unit of P block element, first part, that is 15th group elements. We'll get the complete idea about all properties and some important points of group elements. Then next further part is about some important compounds of 16th group elements. Compounds changes from group to group. That's the main difference between one group to the another group. Okay, take care. Tomorrow I'll discuss some important chemical properties.